Hello, my friends, and welcome to Origins. My name's Donn Chapman. It's my privilege to be your host. You know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. And today we have a great scientist with us who is going to help us to do exactly that. His name is Dr. Russell Humphreys, and Dr. Humphreys is a Ph.D. in physics from LSU. That's your alma mater. And he worked for many years at the Sandia National Laboratories, and mostly in nuclear physics, although you've done all kinds of physics.
Yeah, all kinds. I'm a general purpose physicist.
We're thrilled to have you with us today, and we're going to talk about magnetic fields. Now, I know the Earth has a magnetic field. Do other bodies in space have magnetic fields as well?
Yes, they do. They either now have one or in the past they had one, from all the evidence we have.
Now, you've done a lot of work in this area and actually have developed some theories of your own. Is that right?
Yes, I have.
And we're excited to hear about them, so please share with us.
Okay. First, I should say a magnetic field is what makes compass needles point north. So if you were on some other planets now that still have a magnetic field, they would have a north and a south pole, and the compass would point toward them.
It would point not necessarily north, but wherever the magnetic field was on that planet.
Right.
Yes.
In fact, on some planets, they're not there's some of the magnetic poles are near the equator.
Yeah.
It's
that
funny.
would be interesting.
So, but I was interested in how God started up these magnetic fields, and I found a biblical clue to this that we'll get into this. But the bottom line is that God used water to make magnetic fields on all these planets and stars in the cosmos. So,
the raw material is water.
Right.
Okay.
He started with water and then converted it to other things, but the water was an important clue to me. So this theory that I did a long time ago actually explains the magnetic fields of those planets like Jupiter. Jupiter has a whopping magnetic field. And stars, most stars seem to have magnetic fields that we've observed. And galaxies, big clusters of stars, they have their own magnetic field. And the electrons are what usually makes magnetic fields. In a bar magnet, it's the electrons and the iron atoms. But in water, all the electrons spin in opposite directions, so their magnetic fields cancel out. But the hydrogen nuclei, you know, it's H2, there's two H's, and the center of those atoms are spinning little balls of charge. And those spinning electric charges make magnetic fields. Yeah. They're only 1,000th the strength of the magnetic field of an electron because they're rotating slower. But they're still there. So the hydrogen nuclei in water normally turn, you know, are pointed every which way, so there's no overall magnetic field, and so you don't notice any magnetic effects to your glass of water. But the magnetic fields are there in the little nuclei. So the hydrogen molecule is slightly magnetic, but it depends on which way the spins are in those little spinning balls of charge as to what happens. So why is this important? Because God formed the Earth, and I'm going to suggest all the other big bodies in the sky, from water that He created and then transformed to other materials. And where do I get such a crazy theory as that? 2 Peter chapter 3, verse 5. The earth was formed out of water and by water, or by means of water. And the Greek is even stronger than that particular English translation.
That's, you know, this is one of the amazing things to me about the Bible, Dr. Humphreys, is that here we have a verse where Peter's really not talking about creation. He's really talking about the end of the world more than the beginning of the world, I think, there. And yet, here he just throws in this little phrase, the earth was formed out of water and by water. Yeah. Obviously, the Holy Spirit wanted us to know that.
Yeah, I think He did.
And He included it in God's Word. Yeah. And then, you know, 2,000 years later, the same Holy Spirit that impressed Peter to write that puts into you a desire to understand this and to share it with the rest of us. I just think God's Word's amazing.
I do too. And there's a little clue to it in Genesis chapter 1. You know, the earth was without form and void, and darkness was on the face of the deep. That sounds like a lot of water. And the Spirit of God was moving on the face of the waters. So it looks like my theory anyhow suggests that God made everything first as water and then transformed that water obviously to other stuff pretty quickly.
That's amazing.
But the thing that hit me about that verse was, well, if he made all the hydrogen nuclei all spin in the same direction, all spinning in one particular direction, then all their magnetic fields, those little ones, would add up to a big magnetic field. And I didn't know how big it was, so I quickly calculated it. And it's enough to explain the magnetic fields of the Earth and planets and stars and everything else. So here's a picture right here. Let's see if I can get this thing going. Each one of those is one of those little hydrogen nuclei.
Okay.
And they're all pointed in the same direction.
And that's the key.
In the initial
they kind of neutralize each other out unless they're all going one way.
Yes, if they were all spinning in different directions,
right.
then they wouldn't.
Okay.
And in ordinary water, the molecules bang into each other, and I'm suggesting this was ordinary water. So after a few seconds, all those nuclei would get disoriented. But right at the beginning, the initial instant, they would be lined up and make a large magnetic field, the theory says. Now, I didn't know that my theory would work out to anything good, so this was just a science theory and based on this verse of Scripture. So now, if you figure the strength of the field, it works out to be about 16 times stronger than today's magnetic field on Earth, and that's 7.9 Gausses is 16 times stronger than the half a Gauss or so. That's a physicist term for how much a magnetic field, how strong it is.
All right.
So, so now let's go on with this little theory. Now the created magnetism depends on the mass of the body that God is making, because the bigger the planet, the more water he used to make it up, and so the more magnetic, more hydrogen nuclei all lined up. So this is for the scientist in the audience. The strength of the magnetic field is a certain constant times the mass of the planet, says his theory.
Okay.
So I know how much matter is in all the planets. We know that from various other things, so I should be able to know how strong the magnetic field was when God created it. So then there's something that happens to the magnetic field after that. Oh, I should tell you, in case I slip and say magnetic flux, that's a physicist term. By the way, Michael Faraday, a great creationist physicist of the early 1900s, invented this term, but flux means lines of force. If you plot with a compass needle from a magnet and say put a piece of paper over it, you can plot these lines of force just by following the direction of the compass needle. And these lines of force are important to keep track of if you're a physicist. So when God made the magnetic field first, he produced these lines of force from the spinning hydrogen nuclei. But then what happens in the water is that the molecules would collide and they would make the spins point every which way. But that, according to the laws of electricity and magnetism, would start up an electric current in the water. See, the Earth's magnetic field today comes from an electric current in the core. There's no lined up magnetic fields of hydrogen nuclei today, but within seconds after God created the water, bang, 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 an electric current would start up in the water, just according to today's laws of electricity and magnetism. So there's the current right there.
I guess I don't understand how the collision starts the electric current. Will you help me?
Yeah.
Thank you.
It's the way God made magnetic fields and electric currents to work to begin with, the laws of electricity and magnetism. He made, if you try to change the magnetic field and there's an electric conductor around, and the center of this water would be hot and it would be a good electric conductor. So if there's an electric conductor around, if you flip one of the spins to a different direction, that tries to reduce the magnetic field, and that starts up a little current in the water, to try to maintain the magnetic field at what it was before. And then another spin flips, and another little increment of magnetic field tries to change, and that starts a little more current.
Okay.
And within seconds after all this happens, you're going to have a large electric current in the water, and you're going to have no more lined up spins.
Everything is now one big current.
Right. And you're going to have a large current, 130 billion amperes of electric current. That's a lot of current, even for a big planet. And the magnetic field conserves itself. You see, God made magnetic fields to try to
Want to keep going.
Want to keep going. So very quickly, within seconds, it switches from spins to a big electric current. And it was a large electric current, 130 billion amperes, 6,000 years ago. And that's enough to account for the Earth's field today. Well, the Earth is not made of water right now. It's mostly other stuff, like rocks and silicon and iron and other things like that. So, but the magnetic lines of force, according to the laws of electricity and magnetism, tend to stay the same. There would be the same number of lines of magnetic force, no matter what happened. So, when God transformed that solid, that water into today's materials, the magnetic force would be preserved. So you still have an electric current, but it's now down in the electrically conductive Earth's core, which is 2,000 miles beneath our feet.
Okay.
So now something happens to the Earth's flux after that, but in this transformation it stayed the same. And the mass of the Earth was the same as the mass of the water. So now what happens is that the current runs down like a flywheel. A spinning flywheel has a lot of inertia, it keeps running,
right.
But it's suspended by something and it's running through air, so the friction slows the flywheel down. And the electric current in large planets is just the same as that. It has sort of an electromagnetic inertia, but it slowly runs down because the electric current is meeting resistance in the core, see?
Okay, I understand that.
So just like the flywheel slows down. And so now this is a graph for the techies in the audience, and we're going to plot time in 6,000 years from the beginning of the Earth right here to now. And the electric current would start at that 130 million amperes and decline slowly down to today's I said million, I meant billions, 130 billion amperes down to 6 billion amperes. And it would follow a certain law of falling normally. If nothing happens in the meantime, it would decrease by half every 2,000 years. So now we're down to about a little less than an eighth of the original.
And it's still
current.
declining.
And it's still declining today.
Okay. Should I worry about that?
No.
Okay.
Not unless you're a bird that navigates by the field.
All right.
Some birds have the internal compass.
I probably have enough to worry about, so we'll just let it go.
Okay. So I went and applied, this theory works so well for the Earth that I went and applied it to the planets in our solar system. I use this little law here that the decay time, the half-life, how fast the field decays, depends on how electrically conductive the core of the planet is and the radius, the size of the core. And so that was important. And so in the smaller planets, the lines of force that God created, the magnetic field, decayed fast because the size of the core was small. So now this is another thing for the techies. I'm going to plot the mass of a planet along the bottom, and then I'm going to plot these magnetic flux lines of force on a special kind of graph where the vertical scale is really compressed. And so that theory of mine says the created flux would be proportional to the mass. So you see this blue line along the top here. That's where the theory says the planets started. And by the way, you notice that the sun's right up there and Jupiter's right up there. They're both big, very big objects in the sky, so they have most of the magnetic field that they started with. But the smaller and smaller the planets, the more the deviation from that line, the smaller the field is. So the decay depends on the size of the planet and the material it's made of. So the moon is way down here. Yeah. And its field actually may be less than that. Some of these things they haven't been able to measure a field on, so they know it's less than a certain number. So here's Mars. It doesn't have much magnetic field now, but the Earth has a fair amount still, and other planets in between. So the theory turned out to fit what they had measured for magnetic fields of planets pretty well. Now, let me plot the magnetic field decay on a different kind of graph for you here. This is, again, more for techies, but on this kind of graph, that slow decay works out as a straight line. So planet fields decayed at different rates. And again, I'm plotting time along the bottom from creation to now, 0 to 6,000 years. And my theory gives the magnetic field, or the amount of lines of force, for each object. So the sun started off with a whole lot because the sun is a whopping big mass. Right. And but down here, Pluto, very small, and its moon Charon is even smaller. So they had not much magnetic field to begin with. But each field would decay, and the less the mass of the planet, the faster its field generally decays. And here we have today's moon's magnetic field. It could be less than that. Mars, Ganymede, for example, is a moon of Jupiter. Here's the Earth, planets Uranus and Neptune, Saturn, Jupiter. All of these things, says the theory, would decay at different rates. So we can figure out things about the planet's core, how electrically conductive it is from that, because they can guess at how big the core is, but they don't know exactly how electrically conductive it is. So, well, we find that the electrical conductance, how well it conducts electricity, depends on the density of the planet, and they fall into two groups. So this is electrical conductivity on one side here, and here is density. It's amazing. So you notice there's two groups here. There's planets that are a lot like Earth, that are dense. They have a lot of material packed into a small space in them. Earth and Mars and Venus are all like that. And all their electrical conductivities, this theory says, fall in the same general group. And then there's another kind that's made mostly of gas. They're fluffier, but they're really big, so they're gas giants. Saturn, Uranus, Neptune, and Jupiter all fall into a different area in the diagram. So the theory is happy with that, or at least I was happy that the theory said that. So let's see if I can get it to move now. So I wrote this up in 1984, and the predictions of that theory seem to have all been fulfilled.
The theory seems to say to us that the thicker the mass, the greater the electrical conductivity. Am I saying that right?
If it's a dense planet, it has
more.
Has high electrical conductivity.
Right.
It conducts electricity well.
Right.
But if it's a gas giant, it's low. And that seems to fit the data we have.
And in '84, you wrote up the predictions, and they all seem to have fulfilled, so it seems to verify your theory. Is that right?
Yeah.
We are back with Dr. Russell Humphreys. We've been talking about magnetic fields, and we're talking about a paper that he wrote in 1984, and he took a theory, and you know, when you're a scientist and you develop a theory and put it out there, you sort of put your reputation on the line, don't you?
Especially if you say, if my theory is right, we should see this and this when we get around to measuring it.
You can have a theory if you can never verify it, no one can ever prove you wrong.
Right, and so a good scientific theory, creationist theories should do this, as well as secular theories,
Right.
Should go out on a limb and say, if my theory is right, then we should be able to see this. So,
There's always some people standing there with a saw when you go out on a limb.
ready
That's
to
right.
cut you off.
So how did your theory work out? We have data now to either verify it or prove it wrong.
Yeah, it worked out great.
Super.
The planet Uranus, we'll talk about in a moment, it has a strong field, and that fitted the prediction. And Neptune turned out to have a strong magnetic field, and that fitted the prediction. And it was a numerical prediction, by the way. So, and then Mars has a highly magnetized crust, it turned out. We'll talk about that in part 2 of this show. And Mercury's magnetic field decays very rapidly now, and we'll talk about that in part 2 also. Voyager 2 visited Uranus, and the creation theory that I had gave a number for how strong its magnetic field should be, and it was right in the same ballpark as that. But the other theory, the dynamo theory it's called, the evolutionary theory, predicted 100,000 times smaller. So it really flunked out at Uranus.
So you were 100,000 times more accurate than the other theory.
The other theory was
That's
way
tremendous.
out.
Okay.
Okay. Now the next one, Neptune, also agreed with my prediction, and by that time they updated their prediction for Neptune and said, oh, it's like Uranus, and so both theories said the same thing, but they cheated a little. They
That's right.
So the creation theory said on the order of that number, and the Voyager actually measured right in the same ballpark of that number. So I was very happy about this. And next time we'll talk about 2 other predictions that I wasn't even expecting would be checked.
Okay.
So quite happy about how this turned out.
Well, it's fascinating, and it all began with you reading a verse in 2 Peter that said, God made the world of water and by water. Mm-hmm. And then you began to apply that to the magnetic field, and it's amazing to me how, based on that, God gave you this insight for you to share with the scientific community and with all of us.
Well, it's amazing to me, too. I'm glad he gave me the clue.
You know, my friends, it's so good to have men like Dr. Humphreys who give their lives to studying physics and studying science and saying, does this verify the truth of God and of His Word? And Dr. Humphreys says, yes, indeed it does, right down to our magnetic fields. And this should encourage you to believe in God and to believe His Word and to trust Him, not just with your science, but with your eternal destiny. And today we have Dr. Russell Humphreys with us. Dr. Humphreys worked in the Sandia National Laboratory for over 20 years and has worked in many areas where physics has been applied with his work. It's so good to have you with us, Doctor.
My pleasure.
And today we're going to talk about magnetic fields. This is a second show that we're doing on magnetic fields. And all of this kind of got started with you reading a verse in 2 Peter. Will you share the verse with us?
It's 2 Peter chapter 3, verse 5. The earth was formed out of water and by means of water.
And you began to say that even the magnetic fields, first you studied the earth, but then this is applying way beyond that, that God took the elements or the stuff out of which water was made and used it to make our magnetic fields. Is that right?
That's right. So it provided a clue as to a way that God could have made the magnetic fields of all planets and stars and bigger things than stars even, and we'll talk about those today.
And you wrote this up. You went out on a scientific limb by saying, I have a theory on how this applies to the magnetic fields of really the cosmos, and you said, if my theory's true, and you gave some results that would be discovered that hadn't been determined yet. Will you share that with us?
Well, last time we talked about the planets Uranus and Neptune.
Right.
Voyager space probe had not gone by those planets when I did my theory back in 1984. But my theory gave numbers for how strong the magnetic fields of those 2 planets should be, and the Voyager space probe confirmed those things.
Hit the numbers that you said that would be if your theory was correct.
That's right. And the other side had numbers that were way off, especially for the planet Uranus.
And that's amazing that and validates your theory. Now there are 2 other things that came out of 2 other predictions you made as well.
Yes, and let's talk about those.
All right.
Let's talk about Mars first. Mars' crust is strongly magnetized. And you see, my theory said that Mars would have been created with a strong magnetic field. But since its core is very small, its magnetic field would have decayed away rapidly. We talked about that last time, how fast the fields go away. And so Mars has very little overall planetary magnetic field now.
And it's because their core is different than the Earth, is that right?
That's right.
Yeah.
So my theory said it would have had a strong field in the past, back when God was forming the crust of the planets. So if it had a strong magnetic field, then the crust should still be magnetized strongly. And there was a space probe, Mars Global Surveyor, that swooped very close to the surface of the planet and plotted out its magnetic field. And here you see red and blue areas. The red areas are where the field is northward, pointed up. The blue areas are where the field is pointed southwards. And the strength of the field in those, the magnetization of those rocks, is strong. And this means that Mars did have a strong magnetic field in the past. So it was a validation of the theory, a third prediction.
Now, if I just talk to a layman here for a minute, if I took a compass here on Earth, it's going to point to magnetic north. If I took that compass and I went to Mars, because the magnetization is in the crust, if I stood in different places, it might point different directions.
Yes, and if you had one that pivoted up and down, it would try to point down in one place and up in another.
Because it doesn't have a core or a central place, it's throughout the crust.
Right.
That's fascinating. All right, what else have you got there?
Okay, that was Mars, and then there was another planet, Mercury, that I made a prediction for. And turns out that all of this says that Mercury's magnetic field is young. So let's talk about this graph here. I've plotted for the techies a graph of time from creation in 4000 BC to 2000 AD, 6,000 years of history. And on this graph, the decay of magnetic fields should look like a straight line. So magnetic moment for the techies, that's just a measure of how strong the planet's magnetic field is. And I had a created value, my theory said. And then you see these two little dots down here. The first of them was a measurement that Mariner 10 made in 1975. So I found out that it had a half-life of a fairly small number, 460, 470 years. And that tells me the field is decaying fast, which it should, because Mercury is a very small planet, wouldn't have a large core to maintain the magnetic field long. Another space probe went by Mercury, and that was the Messenger space probe. And it went by in January 2008, and there's a picture of Messenger right there. Its magnetic boom hanging out over the planet Mercury. And I'm going to blow up this part of the graph now so that we can see a little bit more closely. And here's time from 1975 when Mariner went by, here, and the strength of the field plus the error bars. And the blue lines here and here show that slope that I already determined from my theory. And then Messenger measured a field down here with its error bars around here, and that laps over my prediction, but it may even be smaller because there's a clean break between the two error bars. It may be that the Mercury's field is even smaller than I predicted, and there's ways I could adjust my theory to fit that very easily. The other guys are going to have a real problem if Mercury's magnetic field has changed that much in just 30 years.
But it's dropping at the rate or even a little more than what you had thought it was.
Exactly. Which
kind of validates your theory, and in fact does validate your theory.
Yeah, it does.
Fascinating. All right, let's talk about the sun.
Let's get to something really big, okay? This is a plot of what the sun does to magnetic fields. When there are no sunspots on the sun, the magnetic field is kind of simple. It goes north and south, just like the Earth.
Okay.
But the magnetic field in the sun is locked into this hot gas that the sun is made of, and the hot gas is a good electrical conductor, and it tends to drag magnetic lines of force with it. And the equator of the sun rotates faster than the rest of the sun. The whole sun rotates in about 1 month, but the equator rotates in about 25 days or something like that. So
it can do that because it's gaseous and
yes,
it
and
doesn't
so
have
it's
to
like
all move
a strong
together.
wind blowing on
Right,
the equator
okay.
all the time.
Yeah, all right.
But that drags the magnetic field with it. So after a little while, you start to drag the magnetic lines of force with it, see? And after a while, it will wrap the magnetic lines of force around itself many times like a ball of twine. And you see these little dots here?
Yeah.
Those are sunspots where the loops of the field is just twisted and been yanked so tight that pieces of it will pop out of the Earth's surface, and where it pops out and goes back in, it makes a pair of magnetic lines of force that make dark spots on the sun, the sunspots.
You were telling me that the sunspots are a result of the magnetic lines of force.
Right.
And they always come in pairs because there's a place where that line of force has come out and then it gets pulled back in. So you've got an exit point and an entrance point into the gas by the magnetic field. Do I have that right?
Yes. And then the field reverses direction and it starts unwinding and it gets back to this original state where it's a simple field. So it adds magnetic field every 11 years. It twists itself and has more magnetic field, but then it unwinds itself and goes back to its original state.
And it does this on a periodic basis?
Yes,
On
every 11 years.
11-year cycle. That's amazing.
Yeah, that's the sunspot cycle.
Okay.
But when it's in this simple state, it turns out that the field is 80% of what my theory says the magnetic field would have been at the beginning. So the sun is a large body, and yet it's working hard on that magnetic field, yet it hasn't been able to get rid of very much of it in all this time. So sun is, I'm happy with this.
Okay, that's exciting.
So not much energy loss per cycle of sunspot cycles. Now, so the solar system, the whole solar system, including the sun, that data fit the theory only if you meet certain biblical conditions. Now, smaller bodies like the Earth and Mercury and Ganymede and all these other bodies in the solar system, they need a history to explain the data that's as short as 6,000 years. So if the history were millions of years, there would be no magnetic field left in those smaller bodies. And then the planets and sun have to start as water. They can't start as sawdust or iron or nickel or calcium or any of those things because there would be too little B. That's the physicist abbreviation for magnetic field. There would be too little magnetic field, and the sun couldn't have been all hydrogen to begin with like it now is, because then you'd get too much magnetic field. So you have to start with water, and you have to start only 6,000 years ago. So it fits the biblical timescale and this verse about the original materials God created.
That is absolutely amazing.
There's a lot of different stars, but ordinary stars are most common like ours, and they have about the same strength, 10 Gauss for you techies out there, as our sun does near its poles. But there are things called magnetic stars, which have apparently wrapped themselves up like the sun does, but have kept their fields strong, and they're about 1,000 times stronger than the sun. 1,000 Gauss. And then there are these things called white dwarfs, which are compressed, and they've gotten even stronger fields, and that fits my theory too, over 10 million Gauss, very strong. Then these things called pulsars, you've heard about them.
Yes, sir.
They have a whopping field. It's 1 trillion times the Earth's magnetic field.
My goodness.
1 trillion Gauss. And then there are these things, these pulsars, a subvariety of them that seem to have just about as big a magnetic field as anything we've ever can imagine. And that would be 100 trillion Gauss. They call those magnetars. And they don't understand them very well. But that may be the largest magnetic field in the universe, is the field of a magnetar. So now I'm going to plot on a graph for the techies especially the density of different stars, grams per cubic centimeter, from the sun way over here to magnetars way out here.
Okay.
And then the strength of the magnetic field. Now, for most stars over here, this little green area, including our sun, is down here. This red line is what my theory would just predict without the stars wrapping magnetic field around themselves. But if they wrap the magnetic field around themselves a factor of 300 times, then they could get a stronger field. And so magnetic stars are probably that kind of thing. And then white dwarfs are out here. They fit this range, and the pulsars fit this range, and the magnetars are up near the top end of that range.
So your theory covers everything from our common star to the magnetar.
So really exotic stuff out there.
And so the theory, wherever we go, it seems to be valid.
That's exactly right. God seems to have included magnetic fields as part of his original clue to creation.
And Dr. Humphreys, we started with Mars and looked at its magnetic fields. We worked our way up through the stars. Let's talk about galaxies and how magnetic fields affect them.
Yeah, galaxies are big clusters of hundreds of billions of stars, and it turns out they have a magnetic field too. Galaxies
not just
have
the individual stars, but the galaxy, as a whole has a magnetic field.
And this is a plot of the magnetic field of a galaxy that's moderately far away from us, and they can look at the light from that galaxy and analyze it and tell the strength of the magnetic field. So the strength is about 1,000,000 times smaller than the Earth's magnetic field, but it's a great big object. So the fact that it's big has a lot to do with what's happening. It's impressive that it has that much field. And the lines of force that we talked about, see these yellow lines that I've drawn in on top of that same galaxy? It's called the whirlpool galaxy. A lot of our astronomer friends know that, the amateur astronomers. They follow, these lines of force follow the physical arms of a spiral galaxy. And so the magnetic field is locked into those physical arms, and as the spiral arms get wrapped up by the galaxy, we talked about that one of the origin shows,
right.
The magnetic fields get wrapped up right along with it. And so this theory fits pretty good. But I don't know how God made galaxies and how he made the magnetic fields. I can only give you my guess.
All right.
For this.
I would call it an educated guess, though.
I hope it's educated.
Yes, sir.
Now this is my guess. God may have created galaxies as extremely dense water, that he took the entire mass of a whole galaxy, all those stars, and made them as very compressed water. And that would put it deep inside a black hole. This thing is called an event horizon, around which at that point very strange things happen to time and space. But inside that black hole would be this extremely compressed water. And it wouldn't be water anymore, it would be a hot gas instantly after God created it. But there would be a strong magnetic field locked into this water. So it's deep in a black hole, and the mass is hundreds of billions times our sun, and the density would be very high. It would be very dense material, and it would be all quarks within fractions of a second after God created the water. Would turn into quarks, the basic constituents that we know about of matter. So the field would be at 200 trillion Gauss, just from the data, if this guess is right, that's how strong. And the magnetic lines of force, the flux, would be a whole galaxy's worth of magnetic flux lines. Now, a thing that compressed, lots of things happen physics-wise, things that release energy, and this material would come squirting out in several directions, just like if you squeeze toothpaste, it's going to go like that. So this would happen to this object too, and it would make arms of very hot gas called plasma. And the astrophysicists like to talk about plasma jets coming out of objects. And here's a picture that one secular artist made of plasma jets coming out of a black hole. And I'm picturing this as being a thing that made the galaxies, these jets of hot gas. I'm then proposing that God made into stars. So jets squirt from this black hole, and they would have to be 50,000 light years long. A light year is 6 trillion miles, and the diameter of a galaxy is 100,000 light years. So each of these arms would make up half of a galaxy. And there's magnetic fields that's embedded in those jets that is carried out with it. And then the whole object God apparently gave some spin to so that it would tend to wrap itself up. So I'm suggesting this is how God made the stars and the galaxies both. And so here's what would happen to a galaxy. The rotation would wrap up these star arms. Here's an arm along here of a bar of stars that God has made, and He's given it some spin. So that would carry magnetic lines of force with it. So all spiral galaxies look like they've been winding themselves for no more than 0.3 of a billion years, maybe less. But the galaxies are not 10 billion years old, according to their clocks. They're younger. And near and far galaxies look the same, and here I've shown the magnetic lines of force that would be embedded in this to begin with. Now we'll see what happens when it spins.
There we go.
If it spins, the magnetic lines of force would be dragged with it and look like the magnetic lines that we see in galaxies.
Which
so
now starts to look like a galaxy.
Yeah, a spiral galaxy.
All right.
So that's galaxies.
Now, you're saying the distant galaxies' magnetic forces are young. How do you know that?
Because there was a paper that came out in the middle of 2008 that showed when they first started looking at very distant galaxies, their magnetic fields, they found that they had strong magnetic fields. They were expecting weak magnetic fields
because of the age.
They thought
they
those
would
things,
be very old.
Yes,
okay.
were very old. And
now they're seeing that they're normal.
Yes, and that's what my cosmology would say. Their strength is the same as nearby galaxies. This is a nice infrared picture of one of the galaxies. And they're the same as near galaxies. And so that means there's no generator in the galaxies generating the magnetic fields. They were there at their creation. That's what the word primordial means. If you see a scientist use that, he means when it started. He may not be thinking the start was creation, but the fields are just left over from creation.
Now, it says here that the universe may be God's biggest magnet.
Yes.
Help me understand
Okay. That. Well, there are scriptural clues that there's waters above the most distant galaxies. The waters above the firmament.
Okay.
And we won't go into that, but I've drawn it, and it's if there were waters, and those waters were smaller, and God expanded them out, then you can calculate a magnetic field from that. So there would be a primordial, there's that fancy word again, meaning original.
Yes, I understand.
And the theory magnetic field, there's my physicist shorthand for magnetic field, would be a certain small number. Now that number is too small to measure now, but sometime in the future they may be able to measure the field between galaxies, the strength of the field. And I'm hoping they'll find this number. So we don't know, but even though it's a small field, it's a really big thing.
The film is. Yeah, okay.
So that would be God's biggest magnet.
Wow.
So magnetic fields, in summary, they show God's handiwork. They're a fingerprint that He left on creation. And up in the heavens, we see these big magnets. There's magnetic fields of planets, moons, asteroids, meteorites, sun and stars and pulsars, and even these strange things, magnetars, and galaxies, and maybe the whole cosmos itself is a magnet. So like we were talking about, they're a clue to how God made the cosmos, what He made it of, and for nearby smaller objects like our solar system, they're a very definite clue that he made them not long ago, only thousands of years ago, not billions.
This is so exciting. I love the concept that it has, that the magnetic field is, in a sense, God's fingerprint.
Mm-hmm.
Everything he made, to put a magnetic field in to show us that, that he indeed made it, and made it all the same. From our planet to the farthest galaxy, there's these magnetic fields that God put in everything.
That's right.
And I love the hint that you're giving us. I know you can't be dogmatic on the galaxies, but the hints that keep coming through, that it's a young Earth and a young galaxy and young cosmos, after all, that God has made.
Yes.
Thank you. It's been such a privilege having you today, and the insight to magnetic fields is something that myself and probably most of our viewers have never seen as such an incredible testimony to the work of God. My friends, the farther we look, the deeper we look, the more we see the fingerprint of God and the validity of His Word. So don't you forget that it's God's view that He created you, and that should be your worldview too. Thanks for joining us on Origins today. Hope you'll join us again soon, and until then, God bless you, my friend.